Welcome to the Data Edge. I'm Erwin and I'm joined by Stephanie Wiechers, CEO of Pearstop, to break down the complexity of data quality into concrete, actionable steps. We're moving beyond just another tool to show you how to build systems your team can actually trust. If you're ready to turn your technical data into strategic power, you're in the right place. And today we will focus on predictable maintenance. Welcome, Stephanie.
Thank you, Erwin.
Predictable maintenance. Give us a little bit an introduction on the topic, please.
So predictable maintenance is basically when asset servicing companies move from both reactive and just pre-scheduled maintenance to a system where it's possible to derive insights from what's actually happening. How much service do these assets need to, in a smart way, schedule when are we going to service? Are we going to go earlier, later? And how can we predict which parts are going to fail? And then another part of it would be to maximize the total life value of an asset or to minimize the total cost of ownership, where you create an optimum between how much service do we provide and how can we extend the life of this asset in that way.
Okay, that's clear. So, over the last years, predictive maintenance gained more interest and became more popular. So, why do you think that is?
Yeah, it's been a big trend. The reason is there's just so much more possible with technology today. Before, let's say 10 years ago, or maybe even 20 years ago, it was very much the mechanic would go and they would know, right? So they would have this idea of, okay, this machine always fails then and there. And it would be very personal, very localized. Then as more and more scale came to the industry, more and more data became available. And now with big data processing and with the last couple of years, the AI transition, more and more has become possible. And that's why we see this.
Okay, well, that sounds quite straightforward. So people just use the data and then they can work on predictive maintenance. Or is that not the case?
That sounds great, right?
Yeah.
We wish it was that way. Yeah.
No, we run into some hiccups and some barriers. So, guide us through that, please.
Yeah. In theory, that is 100% how it works. So, what our ideal world looks like from I'm obviously saying this from a data perspective, but what the ideal world looks like is we have all of our assets under management. And maybe to make this a bit more concrete is, okay, like let's say we have 10,000 heat pumps under management, which we service, which we plan maintenance, we replace parts, and we just make sure that everything keeps being operational. So, well, if we've got 10,000 of these heat pumps, then we might have information in our system. And again, I'm talking about the ideal world here, where we know exactly how old is every pump, what brand, what serial number, what type. And then what we can do is we can link that to all of our own historical data. How many calls do we have? How much ad hoc servicing do we need to do? How much downtime is there? And just how often do we service these pumps?
Okay, yeah, that sounds interesting. What is a little bit the leverage of benefits that companies can expect if they start implementing, working towards predictive maintenance?
So what we see is having just a call and sending a mechanic is something that's very commoditizable, meaning when we have a basic operation that needs to be performed, there will be so many mechanics that are able to do this. I do need to mention here, of course, there are labor shortages. So, like, you don't always have the opportunity to do it as something breaks down. And so, what comes into play here is when you're not just reacting to your pump breaking down, but you're actually able to assess the risk and the chance that something is going to happen to it and service it actually before you get to that stage, that creates this immense business value because you reduce the amount of downtime that you have.
Okay, so does it also mean that you can reduce the resources that's needed to work on those things? Like if you wait till something breaks down, so then somebody must rush and then solve it as soon as possible.
Yeah.
Is it then different from if you do predictive, or is it still the same people, but you work more effectively and efficiently?
Yeah, good question. Essentially, when you're constantly running to ad hoc cases, there's no means of making smart scheduling, planning, going to the right clients at the right time, maybe combining a visit. So your people will not use their time in the smartest way possible. They'll spend many more hours on the road. Situations will be stressful. They might not always bring the right equipment. Whilst if you are able to move
Mm.
towards more predictive maintenance, you might know that a specific type of pump that is over 6 years old will often require a replacement of a specific part that's not in the standard package. So then automatically you create an opportunity for a mechanic to bring that part. And now that saves, of course, a whole trip back and forth. So you just save hours every time on every service call.
That's really eye-opening that, of course, when you drive in there, you might have a guess what's going on exactly, but maybe no, you don't know what to do and what parts to bring. So that is interesting to understand that. And the other thing, can you say something about what is the, let's say, the impact if you work like with predictive maintenance on the types of parts that then will be replaced, and they must be bought as well, right? So do you see there an impact?
Yeah, we do. It makes it easier to buy the right parts and pieces, to have them in stock, and to buy them at the best or better prices.
Hmm.
Of course, we've been dealing with supplier shortages, and that means that the price of a certain component sometimes really ramps up. When you're able to foresee the need for something, then that allows for smarter procurement.
Basically everybody won that, right? This kind of situation. So,
Yeah,
okay, I'm
yeah,
a service company and I think I want predictive maintenance and I will make the shift
absolutely.
from running around solving issues to predictive maintenance. What do I need?
A clean database. And I'll explain what that means because a clean database doesn't really mean much to most people. So, the way most companies are structured is there are many systems that are running in parallel. So, we'll have an ERP system, we'll have a procurement system, we have a number of Excel databases, maybe project management software. Like we can go up to maybe 25 or 30 different data sources that are used to store different types and pieces of information. Every team will have a couple of products that they work with. And what happens now is because every team has their way of working and the clients also have a way of working, the way that all this information is stored isn't always following the same practices. That's also not possible because we get a lot of data from different clients who have a different type and a different system. And we also can't really expect that when a mechanic does a call out and they write something down, that they're always going to adhere every single practice because their top skill is to repair, right? They're not administrators.
Makes
So to
sense.
overcome that, it's really important to create consistency within a database and to create trust in all the information that's there. To give a concrete example, maybe around these pumps. So let's say you have like a Remea pump. They will often write that down by just the type number or just the type of pump. So that needs a lot of context to recognize, okay, this is the manufacturer, Remea, and this is the actual type number. So when you take the move from reactive to really predictive maintenance and you start improving those call outs, start improving life cycle value, what happens is often you run into this issue that in a database that actually might reflect that you have, let's say you have like 10,000 of the same pump or you have 500 of the same pump. When you look into it and you just aggregate it, the response that your system will initially give you is to say, okay, you've got like 20 of this one, and then you've got 21 of this other type. But actually, they're all the same. It's just that people have been registering them differently into
Mhm.
this system. And every client might have given you a different file. So that's step one, is to sort that out. First of all, create a like baseline of what's in there and make sure that that's correct. And then implement the right quality assurance checks moving forward so that any mistakes are preferably automatically corrected and then also automatically flagged if they deviate from the standard in the systems.
Okay, that sounds quite sophisticated. So, where are we at the current state of technology to actually do those things? Because what you're saying, I get it, because you cannot so much change the behavior of different people because there are, repair service people. On the other end, like you mentioned, you have different clients, so they have different ways of doing things. So that's not really a solution side. So it should be like the data solution should solve it in between, right? So
Yeah.
what are the options nowadays to actually to do what you're saying?
Yeah. There are basically 4 levels of maturity in
Hmm.
that process, where all the way on the bottom, we see you look away, right? It's like, "Okay, we can't deal with this, so we'll keep things as they are." The
Right.
most companies, they solve this by implementing just rigid guidelines. So that is a lot of work because there will be a lot of manufacturers, a lot of types, and it doesn't account for like future looking for any changes. It also makes it really hard and it creates a huge admin burden. But it is workable, and at least it is in that way possible to group this data into categories. Then the smarter ones, what they do is they actually implement QA systems moving forward that not only spot, well, that actually improve the data as you go along. So you might have a team working on this and you have like a number of rules so that the system can automatically pick up parts in it. But then the most sophisticated step that you can take is to use smart software, so machine learning algorithms and artificial intelligence to clean up the database, to automatically link the correct manufacturers, but also to always have all of those quality assurance checks implemented moving forward.
And this
Yeah.
can be related to a specific company and their industry and their way of working.
Yeah. Yeah. It's there is, and this is a challenge, right? There's so much possible. So what I always recommend is make it simple, bring it down to a couple of really like crucial and critical points, realize what industry are we in, what are we actually doing here. And so what we do is we often link a number of databases of like standard manufacturers that are very common. So that gives an extra foundational data
Hmm.
source that can then be used as a cross check. And then on top of that, there is an artificial intelligence layer that spots how do we operate, how do we work, what is our way of registering this, what's important. And it's also able to highlight when something is out of the ordinary and might need some review from the team.
Okay, so people listening to this, when they are interested in knowing more about their specific situation, what can they do now?
Well, um,
Do you have something? Do they reach out to you? And can you help them with maybe a short assessment or something alike?
Yeah, yeah, we do that. So we do help always with a short assessment first, where we would go through what's the data we're looking at here, what's the problem that needs to be solved. So, well, are we moving towards predictive maintenance and what do we want to get out of it, right? So, do we want to give our client advice on how to optimize the total cost of ownership of an asset? Okay, then we have a clear goal, then we boil that down into the steps that need to be taken to move from A to B. The first step is always a data assessment.
Hmm. Okay. Nice. Yeah, that makes sense. All right. So, well, thank you for the, let's say, the first level of insights in predictive maintenance. Really helpful. And it helped me to understand things better. So, thank you so much for that. And I'm looking forward to the next episode, what we will be having next week in the podcast.
It was a pleasure, Erwin. Thank you so
I want
much.
to thank you. Bye, Stephanie.
Bye.